Hello everyone, for this tutorial video I'd like to explain how to use integrals to find the volumes of more complicated shapes than ones you can simply obtain by rotating around an axis. As you are probably already aware, even something simple like a cubic box cannot be obtained by rotating something around an axis because it does not look like an arc or otherwise rotated shape. However, it is still 100% possible to compute the integral by adding layers of the cross-section, as we will see when we do an example. A very easy and obvious example to get us adjusted to doing these types of problems is the volume of a cylinder, which we know has a consistent cross-sectional area throughout its entire height. So you would simply integrate the cross-sectional area from 0 to the maximum height of the cylinder. But we must see that we are integrating with respect to x, and not with respect to radius. So this means we have to add an x after the pi r squared. And we see pi r squared is a constant, so it does not get any special treatment from the integral. Again, because of how the integral was with respect to x specifically. So now that we know the formula for the antiderivative, we would take x equals h minus x equals 0, and we should conclude that the overall volume is pi r squared times h, because pi r squared times 0 is simply 0. And we know it is not appropriate to write addition or subtraction of 0 explicitly. More often than not in these problems, however, the cross-sectional area will not be an easy consistency throughout the entire shape, but rather will require some work to figure out. So if we look at a cross-section of a pyramid, we should see that the overall volume of the pyramid and the volume starting at the cross-section we want to find are similar triangles. So we would use the appropriate formula for the ratio of length of bottom triangle over length of top triangle equals the ratio of height of bottom triangle over height of top triangle. And then use some algebra to get the side length in terms of y. Next, we see because the area is a square, we must square our result. And we see the limits will be between 0 and the maximum height of the pyramid. We see because we are integrating with respect to y, L and h are constants. Lastly, we take the antiderivative of y squared with the power rule, substitute in y equals h. And remember, because for the y equals 0 part, the overall result is 0, we don't have to worry about it. And we should conclude the overall volume is 1/3 length squared times height, because of how height cubed that we substituted in for y divided by height squared is simply height, and everything else stays the same. Although we found this formula earlier from normal geometry tricks in the geometry tutorials, it is always a good idea to double check your work to make sure that you are 100% accurate. Now that I've explained the thought process for finding volumes using integrals that cannot be obtained by rotating a function around an axis, I'd like to transition away from Calculus 1 and toward Calculus 2, because I've gone over every single problem you'll see in Calculus 1 classes in a very comprehensive manner. Don't forget to subscribe if you found this video informative, and make sure to see the other tutorial videos, and follow me on either Facebook or Twitter for more content.